I'm the Director of Education and Outreach here at Biosphere 2, and we're very excited for this two-day collaborative meeting between folks at the University of Arizona and several French institutions and French colleagues. I'd like to especially thank our French colleagues for finding the resources to help us bring students to each of these discussions throughout the day. Biosphere 2 is about research and it's about education and outreach. And this two-day meeting is letting us do both of those very effectively. So we're very excited that you could join us. Thank you. The focus of the meeting is about what we understand about the universe, life in the universe, and what it means to be human now that we have all this new knowledge and this new technology. Because sort of our place in the cosmos, it's a very different way of thinking now than it would have been 200 years ago, right? We know a heck of a lot more. And how does that influence what it means for our future, or what it means to wake up in the morning and think about how special we are, or how special Earth is, etc. So between the two talks that we have coming up and the discussion following, please generate questions. Please think about what you'd like to ask, and I know that we'll be very excited to hear what they have to say, and we'll have an excellent discussion based on the combination of these different views of the world, which is a nice intersection between anthropologists and astronomers, and I'm not sure how often they get together and hang out. So this is really a neat opportunity. So I'm going to introduce, I believe, Istvan Praet, who's one of our French colleagues, perhaps the co-lead organizer on this with Régis Ferrier, which is he's in the front row, and he's going to introduce our first speaker of the afternoon. Thank you.
Thank you very much, Kevin. It is my pleasure to introduce you Istvan Praet, who is an anthropologist of the University of Roehampton in London. Istvan is, after a PhD and a book on the notion of life in Amazonia, I mean the conception of life of Amerindian people of Amazonia, Istvan began an investigation among astrobiologists in order to analyze their conception of life, and also what kind of technical instrument, technical tools, what kind of observation they can make in order to know what can be life in other planets. So, Istvan, I'll let you the floor.
Okay, thank you. Can you hear me?
I think you need to take the
Microphone would be great, because we're recording.
Okay. Oh, right, of course.
Okay, I'll stay here. Okay, so this is maybe a little bit complicated. So for the benefit of the middle school students, perhaps I should say a few words on. So I'm an anthropologist studying astrobiologists. Now, I'm not sure in how far you guys actually know about anthropology and what anthropology is. So I'm just asking you, have you heard of anthropology before? And anthropologists, what does an anthropologist do?
We'd love a definition.
You'd love a definition. Okay, so I'm sort of trying to test the waters. And anyone? What do they study? No, not even someone must have a slight kind of yes. Humans, people, yes, very good. Which kind of, could you think, do you know an anthropologist? Could you think of the name of someone, and what kind of, do they study just any people, or what kind of anthropological study do you normally, yeah?
Is it the study of living matter?
I didn't quite hear that. The study of?
Is it the study of living matter?
The living matter, I guess you could say that people are alive in most cases where we study them. So in a sense, yes, it's slightly more narrowed. So it's really usually just the people, although we're trying to broaden that a little bit exactly here. So yes, so what kind of people do anthropologists usually study? It's usually in faraway countries, exotic places and stuff. That's not, however, the kind of anthropology you're going to hear about from me here today, because in anthropology these days, anthropologists traditionally studied non-Western people in Africa and all kinds of places all over the world. Nowadays, they actually also study people in the Western world, so people like you and me. So they don't have to have these exotic feathers and sort of look very exotic. We actually study scientists, and me in particular here, my current project is on astrobiology, and so I study astrobiologists as an anthropologist. So this is, yes.
But so if they are not different they share the same culture, how is anthropology of people sharing the same culture different from psychology?
Okay. The question is, how is anthropology different from psychology? Here I give you a slightly chauvinistic answer. I think anthropology is far superior to any kind of, I hope there is no psychologist here in the room. Well, if there is, I'm in trouble, I guess. Yes, it's a big kind of thing now. They call it anthropology at home. So in a way, in some way, we are all, also Valerie, who spoke this morning, are linked to this. Okay, so I have to be honest with you. I didn't quite expect you to be so young. So it might be that if I go slightly above your head, please do interrupt me. I'm very happy to explain if I. Okay, so you can ask me questions afterwards, but do interrupt me if it gets too bad. So I'll do my best. Science, but not as you know it. That is how I would describe the burgeoning field of research known as astrobiology. There is both more to it and less to it than you imagine. There is more to astrobiology than its ostensible and rather grandiose aim of searching for life beyond Earth. In fact, the endeavor is much more interesting than this and cannot be reduced to one overarching question, however magnificent or important that question may be. There is less to it in the sense that, notwithstanding its pretends to fathom nothing less than the entire universe, it is also very much a provincial science. Now, to call something provincial may be interpreted as an insult or a critique, but that is not my aim here at all today. Quite the contrary, one of the aims of my anthropological work is to illustrate that astrobiology's...
There's a request from the back for a little more volume. I don't know if we can get this higher, but can you speak? Can you turn it up a little bit? Yeah. Okay, thank you very much.
Okay, sorry about the volume. So quite the contrary, my aim here is not to insult astrobiologists, but show that astrobiology's potential for innovation remains greatly underestimated. So we're actually still underestimating it in some ways. Because it is not just a cutting-edge science in the traditional sense, it is also a hotbed, I think, for unprecedented artistic initiatives and a fertile breeding ground for philosophical experimentation. So, when you look at astrobiology more closely, you do indeed realize that the prevailing narratives of scientific discovery are inadequate, and that the very notion of science is perhaps in need of an update. My long-term ambition is to offer such an update and to forge a language that captures what is really happening in contemporary space research with greater nuance. And one thing I'm particularly interested in is, you could call it conceptual destabilization, and I'll give you a few examples of that in a minute. So basic scientific concepts, long assumed to be set in stone, or at least to be relatively steady and secure, are systematically being destabilized. And I'm not talking about deeply specialized notions here. It could be pretty basic, like moon, planet, life, things like that. And ocean, light, sound, vision. So all these terms, which are part of your everyday vocabulary, are much less solid and much less clearly circumscribed than once believed. And the same also goes for slightly more technical terms. Excuse me. Atmosphere, biosphere, evolution, petri dish. I'll talk about petri dishes in a moment. You could add ecosystems. We had a talk this morning about this and so forth. So within astrobiology, concepts such as these have broken out of the confines of their classic dictionary definitions, so to speak, and have chosen uncharted, adventurous pathways. And my goal is to document some of these pathways ethnographically. I think I will skip this part, but it's an exercise in the anthropology of nature, and we also work together with people in a field called STS, Science and Technology Studies. So it's kind of a joint effort with different kinds of social scientists. And at the same time, it is also, for me, an excursion into the anthropology of art. For I'm convinced that it is not possible to fully grasp what is happening at the frontiers of science if you fail to question the a priori divisions of the dominant modern way of thinking. So the way we sort of tend to think, all of us in our sort of day-to-day life. So we've got these distinctions between observing and constructing, measuring nature, creating culture, discovering and experimenting reality and its models, and then ultimately science and art. So that is what I'm sort of interested in, and how these things are linked. So for my purposes here, I investigate one such division that continues to bedevil modern planetary science, and that is the one between finding, and making. And for the students, I've added a slide, and this kind of sums up my entire talk, pretty much. So you can, but don't worry, I'll go into a little bit more detail. So astronomers, it is commonly said, occasionally find planets. Uranus and Neptune were always waiting there, ready to be discovered by some fortunate scientific hero. Artists, on the other hand, sometimes make planets. Yet it is assumed that these are not actual planets. Such artistic constructions are generally conceived of as approximations, models of, subjective representations, or, if they're particularly good, virtuoso interpretations. Artists are not supposed to find anything, at least not the real thing. So, Kazimierz Malevich planets may figure in overviews of 20th century painting, but they have never made it into astronomy textbooks, as far as I know. Reversely, scientists are not supposed to make anything. The 18th century telescope builder William Herschel simply found Uranus, but had, so it is presumed, no significant creative influence on how the planet became part of our Western cosmology. Herschel may be recognized as a prodigious discoverer, but he is not remembered as an artistic genius. He is a finder, not a maker. And traditionally, that is how it is supposed to be. Scientists are in the business of recording nature, while artists manufacture culture. Within current astrobiology, however, I suspect that this classic division of labor between scientists and artists no longer holds, and the boundary between their respective domains of operation, nature and culture, is becoming increasingly meaningless. You could say that its practitioners have begun to realize that finding necessarily entails making, and vice versa. At its best, you could say astrobiology is an artistic science, or if you like, a scientific form of art. And at this point, a brief word on the notion of artistic research is apposite. So artistic research, as the geophysicist, philosopher and artist Florian Dombois puts it, is premised on the axiom that, and I quote him, "The arts themselves contribute to research and should be taken seriously as alternative forms of knowledge. Research through art demands that we carry out our notion of research beyond such typical formats as a text with appropriate graphs and illustrations. The research of artists who choose to tackle understanding some aspect of the world through their work can result in objects, sounds, and images, among other forms. In this constellation, the combination of the conceptual worlds to the arts and sciences morphs, and our traditional understanding of scientific research and artistic practice is equally challenged and thus begs reconsideration. Now, with respect to planetary investigations, the great pioneers of artistic research are two giants of 20th century painting, Kazimir Malevich and Paul Klee. For Malevich, a prime representative of what art history textbooks refer to as suprematism, this is just the name of an art movement, the artwork was no longer a representation of nature, but a new artificial piece of nature in its own right. And more specifically, he understood it as a new satellite, a Sputnik, a little but nevertheless complete planet. After all, Malevich, and this is in the 1920s, so about a century ago, he envisaged nothing less than the conquest of interplanetary space. So this is a painter, and he sort of understood his own work, his painting, as the conquest of interplanetary space. So he also studied rocketry and devised a detailed plan to construct a ladder up to the moon. I don't know what happened to that afterwards, but so this ladder consisting of various satellites encircling the Earth at different altitudes. And it is not a coincidence that suprematist works of art are also described as autonomous islands, both organic and technological. In the words of the art historian Mitchell Whitelaw, who quotes the artist himself, Malevich imagines the suprematist machine as a spacecraft propelled not by means of engines but through the smooth harnessing of form to natural processes. These forms are so refined, so perfect, that they cleave away from the mundane earth and become new autonomous artificial worlds. All technical organisms are nothing but small satellites, a whole living world ready to fly away into space and to take up a particular position. Indeed, every such satellite is in fact equipped with reason and prepared to live out its own personal life. So maybe I should say this is a painter painting canvases, but this is how he understands, as far as we know, how his way of doing things. So this is maybe it's a little bit weird, but I promise I will try and explain all of that. So the suprematist artwork, Malevich believed, is never enslaved to the form of our terrestrial world, just one possibility among many others, as all previous art had been. His vision echoes Paul Klee's understanding of the picture plane as a self-contained planetoid or cosmos in two dimensions. And I refer once more to Whitelaw, who again quotes the artist himself. It is clear that Klee imagined the picture plane as a kind of contained artificial world. Throughout his Bauhaus lectures on form and composition, Klee can be seen to be exploring a kind of artificial physics for the picture plane, or more, an artificial cosmogony, i.e. the formation of planets. Quote, abstract formal elements are put together like numbers and letters to make concrete beings or abstract things. In the end, a formal cosmos is achieved. There is a strong sense that the artificial world of the artwork embodies not only metaphysical natural laws, but more basic formal rules. The work grows in its own way on the basis of common universal rules. If the form seems organic but somehow unearthly, Klee explains, and this is his own words, entirely different forms may well have arisen on other planets. Yeah. I guess a basic take-home message would be that artists are also thinking about outer space. Yeah, so far that's one of the messages. So to put this differently, Klee saw his drawings and paintings as the creation of two-dimensional planetoids. You could say that he is the inventor of flat planets. The artistic ground that was prepared by people such as Malevich and Klee has proven to be extremely fertile. Think of the sky artist Otto Biene, so I'll show you another artist, who dreamed of designing environments on a large scale using wind as things like wind and fire. So he thought that art must fly, and that's why he makes things like balloons, kites, ribbons, windsocks, and all kinds of, but on a huge scale often. And this sort of all illustrates his vision of the sky, or indeed as the entire cosmos, as a kind of canvas. So he thought about our planet as a kind of canvas. So he didn't just use the usual canvases to put his paintings on, but he thought of the planet as a kind of gigantic canvas. And in this way he complemented the idea that Malevich and Klee held in common. So canvases are not just planet-like, but planets are also canvas-like. And hence the creation of giant open-air installations, inflatable airborne sculptures, holographs, and all kinds of other things, what they call sort of sky art. Biene hoped this art, Biene hoped, will, and I quote, re-establish a more integrated vision of the universe by finding new and meaningful conditions between the extraterrestrial world and Earth. Yeah, so artists were also, in this case, Biene was also thinking about how to connect the Earth with everything that is beyond the Earth. Art, he declared in a celebrated manifesto, is analogous to the solar system. It both reduces and expands planets to human scale. And how inspiring these words were becomes evident when you consider how artists active today engage with planetary science, outer space, and astrobiology. And among others, you could think of Agnes Meyer-Brandis and Andy Gracie. Meyer-Brandis, an installation artist, has drawn a lot of attention with her moon goose experiment, which she describes as a biopoetic investigation, but which could also be seen as a really humorous inquiry into the underpinnings of the analog research that is so characteristic of current astrobiology. So what did she do? By simulating lunar conditions in a training facility of her own design, so she made this in her the place where she produces her art. She made this sort of moon thing with craters and dust and sort of as you would imagine the moon. It had even dandelions apparently grown under non-gravity conditions. So she had been working on this for years, and the aim was to turn geese into astronauts. So she also had, I should have shown this, well, the inspiration comes from this book, which is actually, why is this interesting? It's a very old book, dates from the 17th century, so hundreds of years ago. It's usually seen as maybe the first science fiction book ever, historically. It's called The Man in the Moon, or A Discourse of a Voyage Thither. It was written by an English bishop, and it's the story of a man who flies to the moon. And this was sort of cutting-edge technology at the time. So you see geese and with this contraption. Fascinating story. I won't go too much into it, but what our artist Agnes Meyer-Brandis did in her Moon Goose project. So this is how she got the And on an island somewhere in Russia, she then organized a real or kind of a mock space expedition, which involved a parachutist in a silver flight suit, a chair equipped with meteorological instruments, and survival gear, and a span of 13 specially trained moon geese. So the geese you see there. Now, in a similar vein, Andy Gracie, the other contemporary artist I would like to mention, has long been galvanized by the possibility of visiting Saturn's biggest satellite, Titan. Have you heard of Titan? Yes, you've learned about this? Ah, okay. Yes, you want to say something? No? Okay. I'll just ramble on in that case. Titan, sorry, this is a quote, I should say that. Where was I? Yes, so he's interested in Titan, and he is directly, so this is an artist, directly influenced by the ongoing scientific search for life beyond Earth. So just to say that artists are very much inspired by scientists. That's kind of a key point. So I quote the artist: "Titan," he says, "has become a point of focus for me over the last 3 years. Its ontological, well, its boundaries, let's say its boundaries harbor material relevant to several of my artistic obsessions: astrobiology, space probes, and the origins and possible extremes of life. It is among the places in the solar system that we know best, and it is the one that to date seems most similar to Earth, despite its lack of oxygen and temperatures of 179 degrees below 0 Celsius, so it's very cold there. Titan resembles Earth in its thick atmosphere, liquid cycle, continents, and tectonic activity. For many scientists, it is a kind of model of the early Earth, a kind of iced over an icy proto-Earth. After a careful study of the relation between the atmospheric density and the gravity of the Saturnian satellite, he figured out that a human astronaut would only need to strap on cardboard wings to be capable of flight. So he figured out the atmosphere of Titan is denser, so it would take you less effort to start flying. So you might just flap your elbows a bit, and so that's what he calculated. I don't know how trustworthy his calculations are, but that's not the point. So he sort of had this idea. However, because there are a number of practical obstructions to exploring Titan by means of such winged astronauts, he decided to concentrate on the next best thing. And for some time he has been breeding Drosophila fruit flies in his artistic laboratory. So this is an artist, he has a laboratory, and he breeds fruit flies. And again, this work sort of links with current scientific work done by astrobiologists. So what he did is by gradually shifting earthly conditions towards those prevalent on Titan, and this is done. He does this by means of ordinary materials and everyday tools. So he uses things like bicycle pumps and smoke alarms and even vodka to sort of construct all of that. His aim ultimately is to mutate terrestrial fruit flies into fully functional extraterrestrial ones capable of withstanding higher atmospheric pressures, lower temperatures, and increased ultraviolet radiation. And he calls it Drosophila titanus. That's an image. So this is the fly that he bred in his artistic laboratory to withstand the conditions of Titan. In his own words, so these are Andy Gracie's words, Drosophila titanus employs a mutant strain called vestigial wing, in which the wings are barely formed and on Earth practically useless. However, consistent with my intention to take artistic poetry and metaphor from scientific process is the notion that in the dense atmosphere and low gravity of Titan, the tiny wings of these insects could be able to provide enough lift for flight. Of course, this would only be possible if the flies were able to get to Titan and, despite their intensive acclimatization, survive. The relationship between scientific process impossibility and the artistic gesture is one that I have intended to make apparent throughout all the work I have produced over the years. So this is sort of how he explains his own work. Okay, enough about artists. Now I move to the scientists, the astrobiologists. So, and I ask you to consider the following passage by Charles Coquelle, who is one of the most prolific astrobiologists in Britain, who at some point, so he underlines a fundamental parallel between environmentalism and space exploration, between planets and spacecraft, and between our natural biosphere and artificial life support systems. So this is what he says. Perhaps my favorite way of summarizing the common vision of environmentalists and space explorers is to think of the Earth as a spaceship. To call our planet spaceship Earth has become something of a cliché. The phrase is often used glibly as a means of conveying the fact that we live on a small planet that we need to take care of. Actually, it is a very important phrase because it also underlines the point that learning to live on Earth is identical to living on any other spaceship, whether that is a space station in orbit around the Earth or a base on another planet, such as Mars. It is ironic, he continues, that many people who criticize the cost of space programs prefer to think of planet Earth as a spaceship. By referring to the Earth in this way, they have, perhaps completely unintentionally, agreed that they like to focus on spaceship Earth rather than the International Space Station or human missions to Mars. So even though Coquelle has no artistic pretenses whatsoever, one immediately gets the impression, one hears the echo of Malevich. At least that's what I suggest. Of course, Coquelle talks about engineers constructing spacefaring technology and environmentalists grappling with the big terrestrial cycles, while Malevich refers to suprematist painting and sculpture. But in essence, they are very comparable undertakings. Both are in the business of making and or maintaining spaceships, and hence also in the business of making planets for spaceships are planets, and vice versa. And if this sounds strange, it is only because we have gotten into the habit of believing that veritable planets are simply there and are not something you can make yourself. The awkwardness is the consequence of a deep-rooted prejudice that planets are necessarily big-scale phenomena. Striking parallels do not just exist between the mighty task of looking after the biosphere and the comparatively trivial task of tending our feeble machines in space, as Coquelle has put it, but also with the canvases of Malevich or Klee and the installations of Pine, Gracie or Mayer Brandis. Other astrobiologists have developed very similar ideas. Daniel Bankston, the author of a book on the panspermia hypothesis, has focused on what many contemporary artists consider to be, and have started to use as, a new type of canvas, namely the Petri dish. Invented by the 19th century bacteriologist Julius Petri, these shallow glass containers provide do you know what a Petri dish is? Sorry, I should have stopped and asked you. Yes? No? So a small glass case. You've seen this many times. Okay, so Petri dishes. Invented 19th century, a German guy called Julius Petri, so the name, hence the name Petri dish. These shallow glass containers provide an ideal environment where a few microbes can multiply in isolation from the outside world. Bankston then proposes at first sight overly bold idea. Could we envisage Petri dishes as little habitable planets? Or even more shockingly, could we conceive of our own planet as an outsized Petri dish? And the comparison turns out to be less implausible than you may have assumed. So this is a quote from the astrobiologist Daniel Bankston. So these are his words. So now let's imagine our planet Earth as a gigantic petri dish. Ideal conditions exist on planet Earth for countless species of all kinds to thrive and multiply. In other words, our planet is a gigantic culture media, and proof of this is the enormous biodiversity present. Our atmosphere isolates us from outer space in the same way as the glass cover of a petri dish, since any celestial body that wants to go through it is either incinerated or sterilized due to the enormous temperatures generated when trying to do so at high speed. So what you have here, I think, is a textbook example of the conceptual stretching that is so typical of contemporary astrobiology. And this is perhaps not just poetic license or metaphoric deviation. The Earth is not just like a petri dish, rather the very notion of petri dish, at least this is my interpretation, but I would love to discuss this a bit further with some of the people here. So the very notion of petri dish is expanded to include rocky planets like our own. And again, this is not the same sort of basic idea, comes back time and again. So in my fieldwork, when I talk to these astrobiologists, I sort of heard the same idea time and again. So I'll give you a few illustrations of that. So on the website of the NASA Astrobiology Institute, you find phrases like, and I quote, "Earth's earliest community of complex sea creatures lived in a warm, slimy, planetary petri dish that nurtured a broad array of exotic species." Another example, over its 4 billion year history, and this is the science writer Jeffrey Kluger speaking, the Earth hardened and hydrated and evolved into a planetary petri dish that supported millions of forms of life. The notion of planetary petri dishes has indeed become widespread, and it does not just apply to our home planet. Pondering the likelihood of billions of rocky planets in our galaxy, the astrobiologist Chris Impey, now this is a coincidence, when I wrote this I didn't know I would be in the same session with, so hi, very thrilled to meet you, but yeah, so you remarked, but contradict me if I misquote, do we imagine that all these biological petri dishes could remain sterile? You did say that, I hope. Okay. So this is just one more example. Some of his colleagues dream of breeding Arctic microbes capable of withstanding conditions on Mars. The red planet would thus become, I quote, "a wonderful planet-sized petri dish for evolution under different pressures." And among terraforming enthusiasts, terraforming, anyone? Have you heard of terraforming? What that is? This is kind of a... Terraforming, can you help me, Kevin? You.
As far as the definition?
Yes.
Well, it's
Basic.
yeah, just sort of changing the landscape so that it's producing things that you value, including things like food.
Yeah, so basically people who love that idea, the idea of these planetary petri dishes is particularly popular. So for example, in an article in which he speculates on the possible colors of a future Mars, Robert Walker asks, what happens if we treat a planet, so if we treat Mars as a giant petri dish? Richard Greenberg, and then I'll stop giving you examples, has portrayed Jupiter's moon Europa as a planetary petri dish. So you see, this is not me just, this is sort of comes back all the time. And I could give you more, but so what you yeah, so this is sort of what I found. At a planetary science conference, which I attended in London, a doctoral researcher told me, and these are his words, we astrobiologists, are reluctant to envisage planets as petri dishes only because, he meant like we scientists in general, so are reluctant to envisage planets as petri dishes only because we are confused by our own conventions. Planets cannot be flat and Petri dishes should not be spherical. But once you start thinking about it, the difference in shape and scale is trivial in comparison to the obvious overlaps and commonalities. And yeah, this is sort of my comment on this. I think in all these cases we are not dealing with simple old-fashioned analogies. The basic meaning of Petri dish as a commonplace laboratory device that fits in the palm of your hand is questioned and rescaled, so it's rescaled beyond the human scale. Coming towards the end, so if astrobiologists and space scientists have become infatuated or it's maybe too strong, interested with the cylindrical glass containers that are now a standard piece of laboratory equipment, they are not alone. Contemporary installation artists have developed a very similar obsession. And so this guy, so this is an artist again, so I go back from scientists to artists. Volkhard Sturzbecker, to give you just this example, explicitly makes the link between Petri dishes and planets. His installations evoke living planets, as he calls them. So he basically manipulates Petri dishes and projects them enlarged on a nearby wall, and those who attend his performances have the impression they are astronauts flying, viewing highly dynamic planets full of atmospheric turbulence and geological action. So the awe that these projections inspire follows from the deliberate insinuation that they are not merely two-dimensional representations, but actual planetoids in their own right. Sturzbecker thus challenges the deep-rooted modern convention that you have to be three-dimensional to count as a proper planet. And then, if I wanted to show a website, I don't know if our... Oh, okay. Could you bring up the website? This is just my very last example. Again, a fantastic artist, Sonja Baumel, who does very similar stuff. So I just, to give you this, you can sort of check out her website later onwards if you like. But basically the same idea. So she makes oversized Petri dishes, so gigantic Petri dishes. And please scroll down a little bit and yeah, stop. Yes, this one. Just show it to them. Have no time to take you through it, but she's a fantastic artist, and again, lots of, I think, inspiring ideas as well for science. So there you go. Now to wrap things up. In some way or other, both astrobiologists and artistic researchers are enthralled with the notion that planets are eminently makeable things. They just move beyond an older conception that views them as beyond the human scale and therefore only apt to be found but not made, to be observed but not created. Paintings, artistic installations, spaceships and Petri dishes, it transpires, may be much more planet-like than we used to assume. The artists and scientists that devise them are crafters of planetoids, of little planets, and thereby proceed according to Giambattista Vico's well-known principle that you can only really understand what you make. And I'll stop there. Thank you for your attention.
Understanding what you make, that last line, I think, is very relevant to Biosphere 2. We thought we understood enough to be able to recreate a 3-acre system separate from the rest of Earth's systems, and hope that it would be able to sustain itself and be bioregenerative. And it did pretty darn well, and it's a very useful research tool in addition.